Hello everyone, myself Hans. Today we are going to solve the given problem from differential calculus and the topic is envelopes and envelopes. Question is given, find the envelope of the curves. Curve is given by x is equal to a sin theta minus alpha and the second curve is given by y is equal to b cos theta where alpha is the parameter. Let's solve the problem. Given curve is x is equal to a sin theta minus of alpha. Let this equation 1 and the second curve is given by y is equal to b cos theta, and from here we can also write here this is cos theta is equal to y upon b. Let this equation 2 using the formula sin a minus b is given by sin A cos B minus of cos A sin B. Here we have to use this formula in the equation 1. Then equation 1 becomes x is equal to A sin theta into cos alpha minus of cos theta into sin alpha. And from here we have to put the value of cos theta here, and we have to calculate the value once again. Cos theta is given by y by b, and we have to calculate it here once again the value of sin theta. Sin theta is given by from equation 2 cos theta is equal to y by b. Then from trigonometry we know that sin theta is given by under root of 1 minus of cos square theta. So we have to put the value of cos theta here. We get sin theta is equal to under root of 1 minus of y square upon b square. Here we have to put the value of sin theta here. Then this equation becomes x is equal to a, the value of sin theta is under root of 1 minus of y square upon b square, and the value of cos alpha once again. Here we have to write here this is cos alpha minus of the value of cos theta, we have to calculate it here y upon b, and this is sin alpha. Let this equation 3 and equation 3 differentiating with respect to parameter alpha. So we have to write here differentiating x with respect to alpha, we get here 0, and here this is a under root of 1 minus of y square upon b square, this is constant terms, and differentiating cos alpha with respect to alpha, we get here minus of sin alpha minus of y by b is constant here, and sin alpha differentiating with respect to alpha, we get here cos alpha. Let this equation 4, and from here we have to squaring and adding equation 3rd and 4th. We have to squaring left hand side to left hand side and squaring right hand side to right hand side of equation 3rd and 4th, and then adding. Then we have to get the required result here. So we have to write here the equation 3rd of left hand side is x, on squaring we get x square, and equation 4th of left hand side is 0, on squaring we get here 0 is equal to here, or once again on squaring of under root of a into a under root 1 minus of y square upon b square into cos alpha. We have to squaring and adding. First we have to squaring, we get here a square and under root of 1 minus of y square upon b square into cos alpha minus of y upon b into sine alpha on squaring plus of, similarly we have to add in equation 4th here. This is a square on squaring get here under root of 1 minus of y square upon b square. Here is minus of sine alpha into minus of sine alpha and minus of y by b into cos alpha. Squaring both the sides, we have to squaring left hand side to left hand side, squaring right hand side to right hand side, and we have to adding, and further we have to solve, we get the square result. Here we have to solving here further. From here we get x square, and we have to open this bracket a minus b ka whole square, we get here. First we have to take a square is common, then we have to get here on squaring under root of 1 minus of y square upon b square into cos alpha. On squaring we get here 1 minus of y square upon b square into cos square alpha. Similarly here plus of y square upon b square into sin square alpha, and we have to expanding this a minus b ka whole square in the form of, so we have to writing here this is minus of 2 times of under root of 1 minus of y square upon b square into cos alpha and into y upon b sin alpha. This is a square plus b square minus of 2ab. Similarly, we can also expand this present in the bracket. This is under root of 1 minus of y square upon b square into minus of sin alpha and minus of y upon b into cos alpha. Similarly, we can also expand here. This is on squaring under root of 1 minus of y square upon b square, we get here 1 minus of y square upon b square into on squaring minus of sin alpha, we get here sin square alpha. Similarly, we have to writing here plus of y square upon b square cos square alpha, and here a minus b ka whole square, so we have to write here plus of a minus b, we have to writing here a square plus b square minus of 2ab, but here minus is already present, so we have to write here plus of 2ab, 2 times of under root of 1 minus of y square upon b square into sin alpha, once again into sin alpha and into y upon b into cos alpha, and from here we have to cancel out the terms. Minus of 2 times of under root of 1 minus of y square upon b square into cos alpha into y upon b into sin alpha. Here we can also cancel out the terms. 2 times of under root of 1 minus of y square upon b square into sin alpha into cos alpha. This term is cancelled out, and from here and remaining is y square upon b square into sin square alpha and y square upon b square into cos square alpha. We know that from trigonometry sin square alpha plus cos square alpha is 1. So from here we can also write here once again x square is equal to a square, and the remaining is here. We have to multiplying here. This is cos square alpha minus of y square upon b square into cos square alpha. Here is plus of y square upon b square into sin square alpha. Similarly, we have to multiply here. This is plus of sin square alpha minus of minus of y square upon b square into sin square alpha, and here remaining is plus of y square upon b square into cos square alpha. And from here cos square alpha plus sin square alpha is 1, and minus of y square upon b square cos square alpha, and plus of y square upon b square into cos square alpha is cancelled out, and the remaining is once again and here y square upon b square into sin square alpha, and minus of y square upon b square into sin square alpha is also cancelled out. Then remaining is here cos square alpha plus sin square alpha. We know that from trigonometry the value of cos square alpha plus sin square alpha is 1. So the remaining is x square is equal to a square, and here is 1 multiply with this one, we get here x square is equal to a square, and we get here x is equal to plus minus of a. This is the required envelope of the given curve. Thank you class, and thank you for watching.